Hello children, a very warm welcome again to the virtual session. So let us continue with chapter 6, part 15, physical and chemical changes. Yeah, we are going to continue with the additional questions, and children, you are just going to go through the video. You need not write all the question answers in your notebook, but you have to go through the video again and again. You make a note in your notebook where you will write today's date and the session about about additional questions, and you are going to write today's date, so that if you want to do a recap or review of the session of additional questions, you can easily go to week 10 day 5. Okay, so like that, if you are not writing in the notebook, at least the video you can track, you can go back to those videos, and you can recap you by listening, isn't it children? So it will be good for you. You better make a note somewhere in the book that week 10 day 5, week 10 day 4, whichever sessions we had additional questions, and you have not written in the notebook, at least keep a track of those videos so that you can play it again and again, and you can listen and recap concepts, isn't it children? So let us continue with question number 13. Now you will have explosion of a cracker is a chemical change. Explain. Now when we burn a cracker, it explodes. Explosion produces heat, light, sound and unpleasant gases. That means harmful gases that pollute the atmosphere. Many new products are formed, so it is a chemical change. Quite clear? Clear question. Burning of the cracker produces lots of harmful gases. It will explode. It will give out all this heat, light, sound, which is an indication of a chemical change. Therefore, it's a chemical change. Clear children? Because there's chemical composition of the cracker will change definitely. Now question number 14. Why cannot a chemical change be normally reversed? Why normally you cannot reverse a chemical change? Very simple question. A chemical change, the products are quite different from the reactant. Therefore, a chemical change cannot be normally reversed. Just now we had a question number 13 where you burn firecrackers, the product formed, those are all harmful gases which are altogether different from the firecracker which you are burning. So the chemical change that like digestion, photosynthesis, whatever the raw material you started with, the product form will be totally different. Therefore, you cannot reverse the reaction. Is it clear? Therefore, normally your chemical change cannot be reversed. Question number 15. A student took a solution of copper sulfate in a beaker and put a clean iron nail into it and left it for about an hour. What happened when you add iron nail to copper sulfate? There is some chemical reaction happening which we have discussed in the previous session, children. What changes do you expect? Are these changes chemical in nature? Write a word equation for the chemical change, if any. Now this is from NCERT exemplar. It's a very important question. You have to go through this video again and again. Please go through the video again and again, children, to recap, review, reinforce those concepts. Let us see the answer. A. The color of the solution in the beaker changes from blue to green. What was the question there? What changes do you expect? Now your observation was the color, the blue color copper sulfate solution will change to green. Then a brown color deposit is found on the surface of the iron nail. This is your observation when you do this reaction. That is part A. Part B of the question. The changes are chemical in nature. Why? Because new substances, iron sulfate that is green in color and copper is brown are formed. So solution will turn green and you will see some brown color deposit on the iron nail. Therefore, this is a chemical change. Okay. And you can see the third part of the question where you have to write the word equation. Copper sulfate plus iron. Copper sulfate is blue solution. When you add iron nail to it, or you add a blade which is made up of iron, iron sulfate will turn green, plus copper brown deposit will be formed on the iron nail. It is happening because iron is going to displace copper from copper sulfate solution, which we have done in the previous session, children. Iron is more reactive than copper. That's why it will displace copper from copper sulfate, and this reaction will change the color of the solution. and a residue copper will um, you will find on the surface of the iron nail. I think this question is quite clear with you. We have discussed it earlier. This is extremely important. Describe two changes that are harmful. Explain why you consider them harmful. How can you prevent them? Now you have to describe two changes that are harmful. There are many changes, chemical changes, especially they are very harmful. Burning of petroleum gas and all that, coal tar, all those are very harmful changes. Here we will discuss any two. Explain why you consider them harmful. How can you prevent them? Now let us see why you consider them harmful and how you prevent them. Two harmful changes you can see very easy: rusting of iron, which is an unwanted chemical change because undesirable. Iron is just getting decayed, degraded because of the formation of unwanted substance called rust. Rust is formed because of the attack of oxygen and water vapor in the air. They attack on iron and they chemically react. And what is formed? Iron oxide is formed. That iron oxide is actually rust. That this is an unwanted reaction because that brown flaky substance all the time it leads to decaying of the iron, and we have to face huge monetary loss. Similarly, you have decaying of fruits. You must have seen fruits if you keep at home and you are not in refrigeration. Some fruits will last for longer period of time. It will have a good shelf life. But if you keep it outside fridge, fruits get decayed. We give a foul smell, bad taste. You cannot eat. It's not fit for consumption. So this reaction again is a chemical change. Um, which is not useful at all. Like mangoes, if you keep for longer period of time, it get decayed, isn't it, children? It gets spoiled. Next, rusting of iron is harmful because why we consider them harmful? Because it slowly destroy iron particles and make them useless. Since iron is used in making large numbers of objects or articles such as bridges, grills, railing, gates, and bodies of cars, buses, trucks, and ships, etc. See, at so many places you find application of iron, and because of rusting process, that is a chemical change which happen naturally, is going to give you a huge monetary loss because so many things are made up of iron. Rusting of iron causes a great loss over a period of time. That's why this is how it is harmful to us. Decaying of fruits also, one would not like fruits to get decay. Fruit decay causes health hazards. Due to decaying of food, there's lots of monetary loss in food industry. Yes, you have to be very careful. Those perishable food items, especially fruits, they have a limited period of shelf life. If you don't consume it, then it will get spoiled. So it's of no use then. Of course, we can make manure of all that, but then you cannot eat. Prevention fruits, how you can prevent rusting. First of all, we'll discuss this. Rusting can be prevented by oiling, greasing, or painting. It can also be prevented by galvanization. We have discussed all this, how we prevent rusting. Okay, we are just cutting the contact of iron surface with the atmosphere. First of all, you must be wondering why we are using iron and metal for, at so many places. Why we are making some bridges, grills, gates, railway tracks of iron? Because of its properties of load bearing property. It can bear lots of load, it got lots of strength, and all the other properties of iron. It can withstand so much of stress where no other metals can do. That's why it can be used to make bridges, buildings, and all. And this is the only process which attack iron, and we have to take care. Prevention of foods can be preserved by keeping them at low temperature in the fridge and by using some specific preservatives. So these are the harmful effects of some changes, and there are some preventive measures which we can always take. Question number 17. What happens when an iron blade of knife is deep in copper sulfate solution? What kind of change takes place? It's the same question like when you dip iron nail in copper sulfate. Here you are dipping iron blade. When iron blade of When an iron blade of a knife is dipped in a copper sulfate solution, the iron blade is coated with reddish brown deposit of copper. Okay. Blue color of the copper sulfate changes to light green due to the formation of iron sulfate. So it's a chemical change. This we have already discussed with the iron nail. Here they only replace it with iron blade. Thank you, children. I hope you are going to go through this video again and again. You make a note in your book of today's session, date and the additional questions done today, so that you can easily keep track of additional questions. Thank you and have a wonderful day. See you very soon.